Welcome to Facts and Facts. Besides us human beings, is there other life in our solar system? Any type of life, or hints thereof? How about in our galaxy? In our universe? These questions have been asked throughout recorded history. From our ancient ancestors to philosophers of the ancient world to today's astrobiologists. The idea that there may be other worlds with life has been a thought that has danced on the minds and played in the imaginations of countless humans. Are you one of them? I know I am. Before I continue though, if you like my content, please comment, like, subscribe, and hit the bell to be notified when I release a new video. This helps to grow the reach of this channel and makes it easier to produce my content. Thank you in advance. Now, back to the history of mankind's search for extraterrestrial life. Greek atomists, Democritus and Epicurus, argued that atoms could combine into many worlds. Medieval Renaissance thinkers developed the idea of cosmic pluralism, that the stars might be suns with their own worlds. Giordano Bruno's writings popularized the idea that other planets could host life. With the scientific revolution beginning in 1543 through the 19th century, bigger ideas began to percolate, especially with the invention of the telescope in 1608 and Galileo's improvement of it in 1609. The picture of our place in our own backyard, the solar system, began to be painted. The scale and structure of the cosmos became clearer, and the idea of other worlds became scientifically respectable. In the 19th century, Schiaparelli and Percival Lowell reported canals on Mars, which ultimately led people to imagine Martian civilizations. Nonetheless, the scope of our universe was still out on a yet unobserved horizon. In the early 20th century, the radio era began, and scientists realized they could search for deliberate radio signals from other civilizations. The modern idea that there could be a search for extraterrestrial intelligence grew from the technological possibilities of radio. In 1960, Project Ozma, started by Frank Drake, was the first modern search for radio signals from nearby sun-like stars, and was the experimental beginning for SETI, the search for extraterrestrial life. Drake wrote down the famous Drake equation 2 years later, which shaped the scientific dialogue about how many communicative extraterrestrial civilizations might exist. In 1976, Viking 1 and 2, two NASA lander missions, carried the first dedicated biological experiments to Mars. They were experiments designed to detect metabolic activity in Martian soil. The results were ambiguous and controversial, and the consensus since has been that Viking found no clear evidence of microbial life. However, the missions transformed planetary biology into an experimental science. The SETI Institute was founded in 1984 by Tom Pearson and Jill Tarter. Dr. Frank Drake became the first president of the SETI Institute's board of directors. SETI and other groups professionalized searches for radio and later optical technosignatures. SETI combined engineering, astronomy, and social science thinking about what a detected signal would mean. Discoveries about extremophiles, life's resilience here on Earth, and recognition of widespread organic chemistry led to a new, serious, interdisciplinary field called astrobiology. Astrobiology combined planetary science, chemistry, and of course biology. In 1992, 2 exoplanets were discovered orbiting a pulsar. In 1995, the first exoplanet orbiting a sun-like star, 51 Pegasi b, was discovered. The discovery proved that planets orbit other stars and opened the empirical search for planets that could host life. The question moved from, do planets exist elsewhere? To, which of these planets might be habitable? In 2009, NASA launched the Kepler Space Telescope with a mission to discover planets, particularly Earth-sized ones in the habitable zones of their stars. Kepler discovered 2,600 planets using the transit method, measuring the tiny dimming of a star's light as an orbiting planet passed in front of it. The Kepler mission changed the Drake equation inputs from wild guesses to data-driven estimates of how many Earth-sized worlds orbit in habitable zones. Overall, over 6,000 exoplanets have been discovered to date. With all the orbiters, landers, and rovers, scientists have established that ancient Mars had liquid water, lakes, and environments that could have supported microbial life. Robotic rovers have been seeking biosignatures, assessing samples, and collecting cached samples as a part of the planned Mars Sample Return Program, a step towards definitive lab analysis on Earth. In addition to missions to Mars, spacecraft have been sent to and have found strong evidence for subsurface oceans on Jupiter's moons Europa and Callisto, and Saturn's moons Enceladus and Titan. The Hubble Space Telescope found conclusive evidence of an ocean on Ganymede, Jupiter's largest moon. These moons are top targets to search further for microbial life because they have liquid water, energy sources, and organic elements. Just this year, 2025, a reanalysis of plume samples from the Cassini mission added stronger evidence that Enceladus's subsurface ocean contains complex organics and other ingredients that could support life. This reinforced plans for future missions. Enrico Fermi's simple question, where is everybody? Known as the Fermi paradox, motivates hypotheses about rarity, self-destruction, communication choices, and detection difficulties scientists have regarding extraterrestrial life in the universe. SETI began with radio, then expanded to optical searches using lasers to search for other potential technosignatures from megastructures like Dyson spheres, also waste heat and narrowband transmissions. The WOW signal back in 1977 was a strong narrowband transmission that hasn't been detected again, and it remains a mystery. To date, there have been no confirmed technosignatures ever found. Today, the search continues on two fronts: searching our solar system and searching beyond our solar system. Within our solar system, scientists search for life itself, living microbes, or for preserved biosignatures, past life, using landers, sample returns, plume sampling, and in-depth chemical analysis. Beyond our solar system, the search for habitable planets and biosignatures using spectroscopy and exoplanet atmospheres, technosignatures with SETI, and orbiting and ground-based extremely large telescopes drive this frontier. Kepler, TESS, JWST, the Extremely Large Telescope, the 30-meter telescope, and the Giant Magellan Telescope are leading the search for extraterrestrial life beyond our backyard. NASA's Perseverance and Curiosity, the Dragonfly and upcoming Europa Clipper, and ESA's JUICE mission are searching for evidence of life closer to home. Despite humanity's giant technological leaps, there are still a lot of challenges in the search for extraterrestrial life. The biggest constraints are ambiguity of biosignatures, timescales and rarity, and detection difficulties. Distinguishing weak signals in biosignatures, technosignals, and chemical signs from noise and false positives is technically and statistically challenging. The core of the Fermi puzzle is that life might arise easily, but a technologically advanced civilization may be tiny or short-lived, which would invariably limit their detectability. Even though we found many promising environments and the chemical ingredients for life in many places, there's been no direct evidence or confirmed techno or biosignatures of extraterrestrial life outside of our solar system. Very recently, in September 2025, NASA announced it found the clearest sign yet of past microbial life on Mars. This was based on a rock sample the Perseverance rover collected in July of 2024. We're getting closer and closer to finding life. It's going to take time, money, and continued dedicated effort. But I believe those questions we, humanity, have asked throughout history will one day be answered. And I believe soon. Stay engaged. Before I let you go, Just a quick reminder to like, subscribe, and hit the bell to be notified when I release a new video or short. Also, look for me on TikTok, Instagram, and Facebook. Search Facts and Facts. That's FAQs to always stay engaged.